On Earth, you get about 3 millisieverts of natural background a year. A chest X-ray is roughly a tenth of a millisievert. 6 months on the space station can land near 50 to 100 millisieverts, depending on the solar cycle. A Mars-class round trip can push hundreds of millisieverts into more than 1,000, depending on architecture and solar weather. NASA set a career spaceflight limit of 600 millisieverts. Many Mars designs sit above that line. This is Body Beyond Earth. Episode 3 is Radiation Dose Math. The tax exercise cannot cancel. Space radiation is not one enemy. Galactic cosmic rays are a slow rain of high-energy particles from outside the solar system, including heavy ions that punch deep. Solar particle events are shorter storms from the sun, mostly protons, that can spike dose fast if you are unprotected. Earth's magnetic field and atmosphere block most of both. Low Earth orbit still has some magnetosphere cover. Deep space does not, so the math splits into chronic cruise dose and acute storm dose. You design for both, or you design for regret. The International Space Station is our best long-duration classroom. Typical dose rates sit near half a millisievert per day, with solar maximum often lower for galactic cosmic rays because the sun helps sweep some of that rain away. A half-year tour might land near 50 to 100 millisieverts. Longer tours and solar minimum push higher. Crews wear dosimeters, ops track the score. That experience still sits under the career cap for many travelers. Mars is not another station tour. It is a different radiation neighborhood for a longer bill. NASA's standard 3001 now sets a universal career effective dose limit of 600 millisieverts for spaceflight exposure. Same number for age and sex in the career cap. Separate short-term rules try to keep a solar particle event under 250 millisieverts effective dose with shelter design. Those numbers are not slogans. They are risk management for cancer and other late effects, with hard uncertainty still attached to heavy ion biology. When a mission plan crosses the career line, you are not ignoring physics. You are admitting the architecture needs a waiver conversation, faster transit, better shielding, or a smaller crew risk appetite. Published Mars class estimates often land from roughly 685 millisieverts into well above 1,000 for missions measured in roughly 900 to 1,200 days. Solar minimum can make galactic cosmic rays worse. Solar maximum can cut that chronic piece roughly in half, while raising the chance of solar storms you must shelter from. Surface Mars is not zero. Thin atmosphere and planetary mass help, but you still accrue dose. The honest scoreboard is not one magic number. It is a band that moves with solar cycle, duration, and mass you can afford. Aluminum helps, then returns diminish. Optimized metal shielding might trim galactic cosmic ray dose on the order of 15%. Hydrogen-rich materials can do better, maybe toward 30% in some models, because light nuclei break secondaries differently. Storm shelters with water-equivalent thickness matter for solar events. Active magnetic shields sound like science fiction for a reason. They add mass, power, and failure modes without a clean free lunch. In current mass budgets, you cannot buy your way under every career line with armor alone. Time, trajectory, and biology still sit on the spreadsheet. Faster transit shrinks cruise days and shrinks the chronic bill. Flying near solar maximum can cut galactic cosmic ray load if your storm shelter and ops plan are real. Habitat layout puts sleep and work behind denser stores when storms hit. Dosimetry and space weather watches turn guesswork into decisions. Medical countermeasures and better risk models are unfinished science, not a finished pharmacy. Selection and informed consent matter because the residual risk is not zero for anyone. Radiation is not a vibe. It is a budget with units. Scoreboard the idea. Earth background is a few millisieverts a year. Station tours are tens to a few hundreds across a career path. Mars-class plans can sit at or above the 600 millisievert career line unless architecture fights for every day and every gram. Episode 3 takeaway is blunt. Treat radiation like propellant mass. Count it early. Design the shelter. Shorten the cruise when you can. Do not confuse a thicker wall with a solved deep space problem. Next time on Body Beyond Earth, we open sleep and circadian life on a soul when the day length itself stops matching your brain. For now, remember the cold open. The tax is invisible. The units are not. That is Body Beyond Earth on the Quantum Files. Subscribe if you want the next system when we open it.